Hello friends, I am coming with question number 18 of Pathfinder Newton laws of motion. What is the wording of this question? The question is saying that the three identical balls A, B and C, each of mass m, connected by three identical springs when placed on a frictionless horizontal floor occupy corner of an equilateral triangle as shown in the figure. This assembly is suspended by attaching the ball A to the ceiling with the help of light thread. What can you predict regarding acceleration of the balls immediately after the thread is cut? Acceleration of free fall is g. So all the balls will have downward acceleration. All the balls will have acceleration greater than g in different direction. Acceleration of the upper ball is 3z downward and the acceleration of the lower ball is vanishingly small. And my dear friend, acceleration of the upper ball is 3z downward and the lower ball moves upward with finite acceleration. So I want to tell you, firstly, just look at this is the one ball and this ball is connected with ceiling. So it is connected with ceiling like this. Okay. And another ball is attached. This is a one ball and this is another ball. It is form a equilateral triangle. So these are the form a equilateral triangle with the help of springs like this and like this. Okay, so these are the spring is attached. Okay, so what is happening here? Just look at this ball is experience a force downward mg. This ball is also experience a force downward mg, and this ball is also experience a force downward mg. Understood? And because of these two balls experience a tension, I want to tell you these two balls experience a compressive forces to maintain an equilateral triangle. I will show you these. I have experienced a one force. Let us see. A extension in this springs is called x2. So a compression in this spring is x2. So because of this reason, this ball is experience a force kx2 and this ball is also experience a force kx2. And this ball, suppose the extension will happen in this case is x1 and here the extension will happen, it is also x1 to maintain the equilibrium position. So if these are maintaining the equilibrium position, so here these are experience of force. Let's assure one is kx1 and here it is also kx1 and this side is kx1 and this side is also kx1. So this is the condition before cutting the thread. So once you cut the thread, what is happening? Just look at. So once you cut the thread, only this tension becomes 0. Okay, so this tension is T. So once you cut the thread, suppose you cut this thread, immediately if you cut this thread, the tension becomes 0 and tension becomes 0. So B and C, let's see, this is the A. This block is this ball is called A. This is B and this is C. So the tension force acting on ball B and ball C does not changes. The force acting on ball B and ball C does not changes. So we can say that the acceleration of B and C is same and it is 0. Understood? So we can say that just after cut the thread, net force acting on ball B and C remains same. So acceleration of B equal to acceleration of C and that is called 0. Is it clear? Now what is happening, my dear friend? Here the tension T is balanced, which is what? Which is equal to T initially. In this case, I tell you, I want to draw the free body diagram here. FBD of A. So if you are drawing the FBD of A, then FBD of A is saying that one force is acting upward direction, that is called tension. Kx1 in this direction. Kx1 is this direction. And mg is downward direction. Is it clear? And this angle is theta. This is also theta. So we can say that firstly you can write the tension T is equal to mg plus kx1 kx1 cos theta into 2. Okay. So this is the force. If I'm talking about the kx1, then you can say that in this side and FBD of A is this and B is this. So one force is acting in this direction, that is called kx1, and here it is mg, and this angle is theta. So this side is component is kx1 cos theta. So mg is equal to kx1 cos theta in case of equilibrium. So tension is T is equal to mg plus 2mg, that is called 3mg. If means downward forces, the downward total forces is acting 3mg, which is balanced by the tension. If tension becomes 0, if tension T becomes 0, the 3mg is equal to the m into acceleration of A. So acceleration of A is nothing but it is 3g downward. So this is the answer of these questions. So what is the correct answer? I want to read again. So all the balls will have downward acceleration, wrong. All the balls have acceleration greater than g in different directions, wrong. Acceleration of the upper ball is 3g downward, it is correct statement. And the acceleration of the lower balls are vanishingly small, means it is approximate 0. So this answer is correct. Acceleration of the upper ball is 3g downward, this statement is also correct. And the lower balls moves apart with the finite acceleration, so this statement is wrong. So because of this reason, the D is also not a correct option. So correct answer is C. Thank you so much for watching this video.